let's do some work on adding and subtracting fractions. Well, let's do a quick review, shall we? Just a quick review on multiplication of fractions. 2 divided by 3 times 4 divided by times 6. 4 divided by 6, okay? So those are two fractions, and we want to do a multiplication, okay? So what can we do in order, the first thing we want to do is we want to simplify the expression. Remember that term? All right, now, is there anything we can do to simplify this expression? Yes, anything? You were going to raise your hand back there. You just, okay. Anybody? You don't want to simplify before? You don't have to. We can go back and look at it. So what's 2 times 4? 2 times 4 is 1? We have a lot of work to do. Okay, 8. Okay, 3 times 6? 18. Good. Okay, now, what is the greatest common factor with 8 and 16? The greatest common factor between 8 and 18. What did I say, 16? Sorry, 8 and 18. What's the greatest common factor? Shall we put it out? Okay, 8, 2, you think? Okay, well, let's see. So 8 is going to be 2, 2, 2. And 18 will be what? 2, 3, 3. Therefore, what's going to be the greatest common factor? Just 2, right? Isn't it just 2? Okay, so divide both by 2. Okay, what's 8 divided by 2? 4. Okay, so what you're gonna do is you're gonna factor out a 2, and you get 4. Factor out a 2, 9. And you get 9. So what's the answer? 4 over 9. Is that simplest form?
Yes.
Yes, it is. Now, what could I have done before I did the actual multiplication in order to get a product that's already simplified? What could I have done? Larita? You got to speak up. I can't hear a word you're saying. You're saying right in front of me. Here? You're talking about here? No? What are you doing? 2 and 6. What's that mean, 2 and 6? Is that code for something?
No.
Simplify 2 and 6. You mean this 2 and this 6?
Yes.
You want to do that instead? Okay. So what do I do? Divide, go ahead, tell me. 2 divided by 2 is 1. Okay. 6 divided by 2 is 3. So 1 times 4 is 4. And 3 times 3 is 9. What else could I have done? Anything else? Is that it? Yes?
You can change the denominator.
I can change the denominator to what?
18.
A what?
18.
80?
18 or 6.
I'm not sure what you're saying. What do you want to do?
Like, you can change the denominator.
You want me to change this denominator?
Yeah,
To what?
to 6.
Why would I do it to 6?
And then we can multiply it.
But this is multiplication, not addition. Even if it were addition, you wouldn't be doing that, right? You want to come together with an idea back there, maybe, or you okay? Okay. So, couldn't I have said that I could have divided 4 by 2 and 6 by 2 instead? Could I have done that over here instead? Could I?
Yeah.
Could I? Well, let's see. Let's see if it works. So 2 divided by 3 times 4 over 6. All right. So what would I? Could I have divided this by 2?
Yes.
And what would I have gotten?
2 over 3.
2 over 3, and that's going to be 2 times 2 is
4.
4 over
9.
9. Same thing.
Yes.
Yes. Okay. Easy. Okay. Are we ready to move on? You want to do one more problem, maybe on division? Yes? Do one more problem? What time is it?
10:53.
What is it?
10:53.
All right. 2 over 3 divided by 10 over 4. Okay, so what do I do? What do I do?
Inverse.
I can take, what? How do you say that in math? Sound mathematical, Rita. Write this down, everybody. Write this down. Larita, how do you say it? You want to try it out? No, you can. You're only going to be wrong. I mean, it's not a terrible thing. You just...
Is it convert?
No, I'm going to say
No.
2 over 3. Let me start you off. Let me help you, okay? Times what? 4 over 10. That's right. So what you're doing is you are multiplying. Gentlemen, thank you for paying attention. I've already moved on and started the problem that you may not understand now. So you've got to be with me, right? Right. What you're doing is, when you have division, you multiply by the reciprocal. What's the reciprocal? What does that mean? What's the reciprocal? What does it mean? What does the reciprocal mean? What's the reciprocal? Anybody? What's the reciprocal of A over B? B over A. What you're doing is you're simply exchanging the denominator and the numerator. Can you please shut the computers? Thank you. Right, I said that about 7 or 8 minutes ago. So you're simply exchanging the numerator and denominator, correct? That's the reciprocal. Yes or no? Is that clear? Yes. So now what can I do? Can I simplify this in any way?
Yes.
How can I simplify this? Someone other than Larita. Anybody? Erica? No? No, Erica, that's another class. Is that another class? Sorry, wrong class. Eric, yes. Yes, go ahead. How can you simplify this before I multiply? Go ahead. 2 over 5 instead of 4 over 10, right? Now, one of the ideas with mathematics, especially when you're young, is you've got to be very, very specific. You can't be sloppy. You got to be extremely specific. Understood? That might be part of your problem. You've got to be extremely specific. Okay. Now, Eric, what am I doing specifically? Yes, you're right, 2 over 5. But what am I doing specifically? Go ahead. Put it in words for me. Yes? And what's the greatest common factor between 4 and 10? 2. And then what am I doing? I'm simplifying, but before I actually pull the trigger and simplify, what am I doing? I'm going to divide the numerator and the denominator by that greatest common factor, aren't I? Say that, Eric. Okay. You're going to divide the numerator and the denominator by the greatest common factor. So, 4 over 2, 4 divided by 2 is? 2. And then 10 divided by 2 is? 5. So that's going to become, right, you're going to rewrite this as 2 over 3 times 2 over 5, aren't you? Correct? Yes. Now, what is 2 times 2? 4. Good. And what is 3 times 5? 15. Yes or no? Are you with me? Now I want to just at least do one problem where we're looking at addition and subtraction. Even though this is kind of a bit of a review. It's been a while since we've had class. Seems like that, doesn't it? Yeah. So let's do a couple of problems. Let's say 2 over 3 plus 3 over 6. Okay? Now, what do I have to do when I do when I do addition or subtraction? What do I have to find? Yes?
Same denominator.
What do we call that? No, what do we call that? What do we have to do to come up with the same denominator? What's the words? Okay. Go ahead. Go ahead. Put in words. Go ahead.
Is 1 over...
No. I want you to put it into words. You got to explain to me specifically what you're doing. What are you doing? What do I need in the denominator? Don't I need a common denominator?
Yes.
Don't I need a common denominator? Right? Doesn't it have to be the least common? Don't I need the least common denominator? How do I find the least common denominator? What do I use? Least common denominator. What do I use for the least common denominator? We studied it in the last chapter.
Multiple.
The least common multiple. Don't I need the least common multiple? Don't you think? So what's the least common multiple between 3 and 6?
3.
3 is the least common? So 6 goes into 3 evenly? It does. So I can divide 6 into 3. How many times?
2.
You can divide 6 into 3 twice. Or you can divide 3 into 6 twice. I asked you what the least common multiple is between 3 and 6, and you said 3, right?
6.
6 you mean, right? Do you mean 6 or do you mean 3? What do you mean? 6. Well, let's do this. 3. What are the prime factors of 3? 3, just 3. 3 and 1, right? And what about 6?
2, 3, 1.
2 and 3, right? Yes? Correct? So you pick one representative of each. What do you got? You have 2, 3, right? 2 to the first, 3 to the first. And what does that equal? What's 2 times 3? 6. So what's the common denominator?
6.
What's the common denominator? 6, right? All right. How do I change this?
2 times.
How do I change that? Constant. Not what. How do I make 2/3 with a denominator of 6? In other words, constant. I have 2/3, right? What did I do to 3 to get 6? What did I multiply by?
Times 2.
Times 2. So don't I do this? Yes or no? Yes or no? Just asking you.
Yes.
Excuse me. You did that once before. Thank you. I appreciate that. Appreciate your support. So this is 4 times 2 is 2 times 2 is 4. Okay? So that takes care of that, right? Yeah. Did I have to do anything special to 6 to get 6?
No.
So that's just going to be what?
3.
3, right? So what's the answer? I don't know, but we're going to finish this problem regardless of what it is. What's the answer?
7 over 6.
7 over 6, yes?
Yes.
Okay, easy? That's your one problem? All right? Are we all done? All right? All right, we're off.